Page 7 of differentiation. Okay, so on this page, there's a couple more business scenarios, and even though they're business scenarios, I think that even the non-business people have probably done enough of these to get used to it. Okay, so number 5, a business buys engine parts from a factory. The business is currently deciding which of 3 purchasing strategies to use for the next stage of its development. Its researchers produced models for each of the strategies. P is the expected profit in 10,000 euros. What does that mean? If P is 3, for example, that means 30,000 euros. It's like they abbreviated the quantity in money. And N is the number of parts it buys in thousands. So like, for example, if it was 5, N equals 5, that would be 5,000 parts. The largest number of parts the factory can sell to its business is 5,000, and there is no minimum. Okay, basically this is a sneaky way of giving us the domain. Okay, so the N value, it can go up to 5,000, but N is in thousands, so that means N is going to be between 0 and 5. Okay, for each model, find the maximum profit and the number of parts the business needs to buy to make this profit. So basically, we're just finding the maximum point of each one of these functions. It's not really a business problem. It's just a math problem. It's just a calculator problem, actually. What I'm gonna do first is I'm gonna type these into the calculator. Of course, I'm gonna replace the n's with x's because there is no n in the calculator. And like, for example, 4 divided by n plus 1, I could either do that with parentheses around everything, or I could use the vertical fraction. So I'm going to put 4. Then I don't need to put parentheses around anything. X plus 1. Okay, that's one of the strategies. Another strategy is x cubed. Ooh, but x cubed divided by 3. So I'm going to use the vertical fraction again. Put x cubed on top. And I'm going to put 3 on the bottom. And then I'm going to put plus or minus 5x squared divided by 2. So there I go again. I'm going to put the vertical fraction again. 5x squared. So 5x squared on top, 2 on the bottom, and then 6x minus 4. Last of all, x cubed divided by 24. Minus 5x squared divided by 8. Oops. Five x squared divided by 8 plus 3x. Okay, and I'm going to look at the first strategy first. So I'll leave that equal sign on. This is a very useful thing. I'm going to turn that one off by clicking enter on top of the equal sign. See how the equal sign is not highlighted anymore? Now only the blue one is going to appear when I graph it. Oh, by the way, what's my domain? 0 to 5. Let me just make sure my x, 0 to 6. So let's change that to 0 to 5, because I know that I'm only going up to 5,000 or 5. Okay. All right, so that's strategy number 1. And the maximum profit looks like it occurs right at the beginning. Isn't it right there? So it's actually the y-intercept. So let's check what that is. What is the y-intercept? We can look at the table and find the y-intercept. It's 5.5. Okay. You can see from the values here that the 5.5 is bigger than 4.6667. So the maximum profit is 5.5 and it occurs at 0 parts. That's kind of useless to make the maximum profit is when you make 0 parts. So basically you're not making anything. Okay. So now we are going to check the second strategy. So we turn off the first strategy equal sign. And then we turn off the first one, and then we turn on the second one. And then we're going to graph the second one. And we don't see it. So maybe it's higher. Maybe we can't see it because it's too high. So let's do zoom fit, which is 0, option 0. It's down here. Enter. Okay, so it looks like the it looks like the maximum profit is also at 0. Let's see. Let's look at the table. Yeah, so the maximum profit is the second one. The highest profit is -4, which occurs also at 0. Okay. These are terrible. Okay, what about the third one? So let's turn off the second one. Turn off the second one. And then we turn on the third one. And then we graph that. Okay, we need to change the zoom fit again. It's busy graphing. Okay, now we're going to zoom fit, which is 0. This is better. Okay, so strategy 3 actually has a peak right there. So let's find out what that strategy is. Second calc, maximum, and then the cursor's already on the left side, so we hit enter, and then we move the cursor to the right side of the peak. And then we hit enter again, and then we guess, enter. And the answer is 4, 4.67. Okay, so obviously we should use this strategy 3 because this one is always negative, right? And this one is it's 5 point it's like 5.5, but it occurs when there's 0 parts made. So you're not going to make any money anyway. Let's graph the first one and the third one just to compare them at the same time. Okay, so we're going to turn on the first one and the third one, and we'll graph them both together. Okay, so now you can see that actually the black strategy is good starting at this point here, right? So the black strategy is better starting at this point all the way to this point. So let's find out what this point is. Second calc, intersect, enter, enter, enter. So the intersection is 2, 3.83. So we should use this strategy for x is greater than 2. And then we should use this strategy for when x is less than 2. Okay, so the blue strategy is better for low volumes, and the black strategy is better for higher volumes above 2. Okay, it looks like right before you get to 5, they cross back again, but I don't think that's significant. We don't need to worry about that. All right, let's go to the next problem. Number 2. A company's profit in thousands of dollars can be modeled by the function, gives us a function, where x is the number of units sold in millions each week. Sketch a graph of p of x for 0 to 15. Calculate the instantaneous rate of change at x equals 3, x equals 8, and x equals 13. Explain the meaning of these values. Okay, so now they asked for instantaneous rate of change. What's instantaneous rate of change again? It's the derivative. Okay, so now we need to find the derivative function again. But the first thing we're going to do is we're going to sketch the graph of p of x for 0 to 15. Of course, we're going to use the calculator to help us do that. Okay, so I'm going to put in 0.08 x cubed minus 1.9 x squared. Oops, x squared, not star squared. Plus 12.5x. And I'm going to, we'll use the table first. Okay, and so from the table, we can get some points here, and we can graph the function from 0 to 15. Let's see, we'll use this graph paper here. So, for example, 0, 0 is a point. 5, 25. 5, 25. Let's see, 2, 18. 2, 18 is here. 2, 4, 6, 8, 12, 14, 16, 18. Okay, and let's see what else. 10, let's see, 7, 21.84. No, we'll do 8, 19.36. Okay. And then we'll move down a little bit and get some more points. Okay, we're going to graph up until 15, right? So 15, 30. 12, 14.64. That's pretty good, right? Let's graph this. Something like that, okay? And let's look at the graph to see if we're close. Just going to do, adjust the window. We're going to do 0 to 15 on the x, and then for the y, we'll do 0 to 30. And then it should pretty much like this. Okay, yeah, pretty good. All right, let's see what it, oh, by the way, let's label the axes. So this is P, and this is X. So the profit, and X is the number of units sold in millions. Units sold in millions. And this is profit in thousands of dollars. Okay, profit. All right, it says to find the local maximum and minimum points. Oh, calculate the instantaneous rate of change at x equals 3, x equals 8, and x equals 13. All right, so in order to calculate the derivative values, first we need to find the derivative. What is the derivative of this function here? So the derivative is going to be 0.083x squared minus 1.92x plus 12.5. Now I'm going to graph this function. Now you could simplify this, right? I could multiply the 0.08 and the 3 and I would get 0.24. I could multiply the 1.9 and the 2 and I would get 3.8. Okay. Now I'm going to type this in the calculator into y2 because the derivative goes in y2. So I'm going to put 0.24 x squared. And then I'm going to put minus 3.8 x. And then I'm going to put plus 12.5. Okay, and that's the derivative function. And I'm going to look at the table because they asked me to give them the derivative at 3, 8, and 13. So the values would be, so at x equals 3, the derivative is 3.26. At x equals 8, the derivative is negative 2.54. And at x equals 13, the derivative is positive 3.66. Okay, what is the meaning of these values? So basically these are rate of change of the profit with respect to the number of units sold. So like when you, now 3 is not actually 3, it's 3,000, I think, yeah, 3,000. So when you're making 3,000 parts, the profit is going up at $3, well, it's not $3, it's $3 million. Is that right? $3 million. It's going up at $3 million per thousand. Okay, and then at 8,000 parts, the profit is going down $2 million per thousand. And then finally, at x equals 13, which is 13,000 parts, the profit is going up at $3 million. So basically, like, if you're making 3,000 parts, you want to start making even more because you're going to make even more profit as you increase the number of parts. Now, when you're at 8, you're at a position where it's like the more you make, the worse you do, the worse profit you get. Okay, and you can kind of see that from the graph because on the graph you saw that it like went up. So like, you know, when you're going from 0 to here, then you're like, whoa, the profit's increasing. But like as you go from here to here, even though you're increasing the number of parts you sell, the profit is going down, right? Okay. Part D. Oh, we need to find the local maximum and local minimum parts, minimum points. So let's do that. So first of all, we don't want to graph the red function because it's very confusing to see the blue function and the red function together. So we're going to turn that off. Then we graph, and we're going to do second calc max. And then we'll find what this point is. Enter, enter. So 4.66 and 25.1. 4.66 and 25.1. Okay. And then let's do the minimum, second calc minimum. And then we'll look between this point and we'll move the cursor to the right of the valley and then hit guess. So it's 11.2 and 14.1. Okay? So that would be the minimum point. And what else do they want us to do? State the values for which the instantaneous rate of change is positive. State the values of x for which the instantaneous rate of change is negative. Explain the meaning of each of these results. Okay, so I'm going to mark with green highlighter when the instantaneous rate of change is positive. Basically what that means is, when is the slope positive? When is the function going up? It would be these two intervals, right? When is the function going down? That interval, okay? So basically, the green intervals would be 0 to 4.66, right? And also 11.2 and above, all the way to 15. And then the red intervals would be from 4.66 to 11.2. Okay, so the red intervals is when the profit is going down every time you make a new part, and then the green intervals are when the profit goes up when you make a new part. Yeah, so basically we've explained that. That's part D. All right, that's it.